given that the roots of this equation are alpha and beta, we're asked to basically consider alpha plus beta and alpha beta to determine the exact value of this. So you've got to learn that the sum of your roots is always equal to minus b over a. And then the sum, when you multiply them, is c over a. And you just alternate the signs. The next one here, alpha, beta, gamma, would be minus d over a. But we don't need that here because we're dealing with a quadratic. And I'm talking about the quadratic, in this case being ax squared plus bx plus c equals 0. So for us, a is 5, b is minus 3, and c is 12. I'll derive these at the end. They're ones that you should be able to derive, but the key thing is remembering the formulae, and it's just like a nice little system. We just sum the roots individually to get minus b over a, and you just increase you go further up in the alphabet for the top, and you get rid of the minus, and you just alternate from there. So we can say that alpha plus beta, because that's what this first one is going to be minus b over a, so it's going to be 3 over 5. That's a good start. And then alpha beta is going to be c over a, so 12 over 5. Okay, brilliant. Right, and I want 1 over alpha squared plus 1 over beta squared. But I don't have, I mean, you could try and solve these simultaneously, but you don't need to. Instead, just going to play around with this, add the fractions together, put them over a common denominator of alpha squared, beta squared. So times this one through by beta squared over beta squared. That gives beta squared over the top, on top, and this one alpha squared. So that's what we can turn it into. Okay, and then that is going to equal, well, alpha squared plus beta squared is actually alpha plus beta all squared minus 2 alpha beta. And here we've got alpha beta all squared. And we're basically ready to sub in then. So I'll have 3 over 5 all squared minus 2 times 12 over 5. I'm just going to go straight for it, 24 over 5. And it's all over alpha beta all squared, so that's going to be 12 over 5 all squared. To use your calculator for this, we were asked to show detailed reasoning, so I think I'm going to avoid it. I'm going to get 9 over 25 minus 120 over 25 all over 144 over 25. And you can actually just get rid of these, or you can kind of keep change flip and get rid of it after that. That'll give me minus 111 over 144, which is the answer, except we just got to see if we can cancel it down. I think 3 goes into it, so just put it in our calculator, to be honest, to get minus 37 over 48. Okay, I did say I was going to derive the original formulae, so I'll stick to my promise. We've got ax squared plus bx plus c equals 0. Going to divide through by a. And I know that I can write it, I can factorize it, giving roots alpha, wait, not alpha, I need to make it x minus alpha here. If I want my equation to have roots alpha and beta, then I know I can factorize it like this. I mean, they might be complex, we don't know, but that we can say that. So they are equal to one another. And then I'm going to expand it to give me x squared minus alpha plus beta times x, once I've expanded that, plus alpha beta. And from there, we just read off the coefficients. We can see, actually, let me start with this one. We can see that b over a is going to equal minus alpha plus beta. That means alpha plus beta is minus b over a. And we can see that c over a is alpha beta. So you can do similar with the cubic, the quartic. Highly recommend you do so to practice it from time to time. And then it's a case of just remembering, to be honest, the nice formula that is kind of all, it just keeps on going in this kind of pattern, not too bad, and it will work for your quartics, cubics, and or quadratics that you need for this AS further maths.